Okay, let's see how we can implement this program. So in order to make sure that we can get rid of all those fake transitions, what we have to do is that instead of triggering the counter directly by our sensor input, we can trigger a timer here first, and then using the TT bit of the timer to trigger our counter. So here I have my counter. Here I have my timer. Let's say this is, for example, T4 0, and here I have C5 0. So this is a counter and this is a timer. So instead of directly triggering the counter by the sensor input, which has a lot of transition similar to what you can see here, I'm triggering a timer with the signal. So as soon as the timer will see the signal with the first false to true transition, it will be triggered and it will produce this TT signal. This can be the TT signal of my timer. Then this TT signal, which does not have any oscillation, can be used to trigger my counter. Now the only problem is that the sensor input is just going back and forth between 0 and 1, and if I use that signal, then the timer will be reset to 0 every time that the transition happens. So in order to avoid resetting the timer every time with every oscillation, I have to use TT bit here as well. So here I have to use T4 0 TT bit, and I have to use it here as well, T4 0 TT bit. So by using this one, I can make sure that as soon as the first transition is happening, the timer is activated, and using TT signal, it will remain active until the end of this 0.5 second. And if I trigger my counter with a signal like this, it will only see one transition, which is a correct number for the number of bottle I'm looking for. So then I can use my counter output, counter done bit. So whenever C5 0 done bit is 1, I can turn on my output field device. So in order to get rid of all those fake oscillation, this is basically what I need to add. I need to add a timer to help me mask all those oscillation, and then I'm gonna use the TT bit of the timer to trigger my counter, which does not have any of those oscillation. The only thing that is very important here to remember is that the time that I'm choosing for my timer should be somewhere between the end of all those oscillation and before I can assume the second object can be seen by my sensor, somewhere here. So I'm assuming that 0.5 second is a period that I cannot have more than one object during this period, and at the same time that one object has passed my sensor. Okay, now let's go to the last application that you might want to use a counter for. The last application that's application number 4, and that's up and down counter. So if you need an up down counter at the same time, what you have to do, if you need a counter that can count both up and down, which means it can increment and decrement at the same time, then you need to add one CTU and one CTD to your program. Let me give you an example. Let's assume that you have a parking and you are using two sensors. For example, sensor 1, which is looking at the cars that are entering the garage, and you are using another sensor, for example S2, which is looking at those cars which are leaving the garage. So in this case, you want every time that S1 is activated, you want to count, you want to increment, and every time that S2 sees an object or a car, you want to decrement. So you need to have an up-down counter, but in Allen Bradley, we don't have one instruction as up-down counter. What we have to do is that we have to use one CTU, one CTD together, and then we can consider it as an up-down counter. I'm going to show you how the program looks like. So let's assume that S1 is connected to my CTU. So this particular input can increment the accumulator value. And then S2, which is supposed to show me the number of cars that are leaving, needs to be connected to a CTD, which is a down counter. Now, the only thing that you should be careful is that because they are supposed to work with the same accumulator, so S1 should increment an accumulator that S2 is capable of decrementing it. So then you have to use exact same address, or in other words, you have to work with the same accumulator value. So because of that, you need to use same counter number. So both of them should be, for example, C5-1 here and C5-1 here. If you use two different numbers here, then basically there are two completely different counter with two completely separated accumulator. But if you use same address, it means that, let's say this is your memory table and this is your C5. So in C5, if you are using this particular block, which is your C5-1, so this portion is the accumulator of this particular counter. So whenever S1 triggers, then this accumulator will be incremented, and whenever S2 trigger, the same accumulator will be decremented. So this is how you can combine a CTU with CTD. The only thing you have to do is that you have to use the same memory address for both of them, which means that you have to have access to the same accumulator value. Then in your program, you can use the done bit of this counter to turn on your output field device. For example, here I'm using C5-1 done bit to turn on my output. And if you need to reset the accumulator, you can use a reset switch and connect it to a reset instruction, which has the address of the same counter.